Hi, this is Maggie. In this video, we're going to look at how to debug a recursive program. This video assumes that you already know how to use the idle debugger or another debugger, so if that tool is unfamiliar to you, you should review the sections of the textbook that go through debugging or review prior debugging videos. And of course, this video also assumes that you're familiar with functions that take parameters and return results and the call stack, and ideally, recursion. Before we get started, I'm going to quickly give you some tips for how to get the most out of this video. First, if you have problem solving with Python, read up through Chapter 7. If you don't have it, you can still learn a lot from this video. Open up idle and follow along with Python as I work. Sometimes I'm going to suggest you pause the video and complete some steps on your own. When I do that, pause the video and do your best to complete the steps on your own. The way to learn to program is by programming. You can watch and learn if you work along with me. Remember, you can always pause the video and try something, or go back and watch again. You don't have to wait for me to tell you to pause. There are some automated exercises in the description of this video. The exercises work with the same code or similar code to the code in the video. After you've completed the video, try the exercises to cement the concepts in your mind. Now let's get started. We're going to continue from the recursion problem-solving video, so you might want to refamiliarize yourself with that problem and that solution. Briefly, we wrote a recursive solution to compute the hailstone sequence, a sequence of numbers obtained by dividing an even number by 2 and proceeding with the result, and multiplying an odd number by 3 and adding 1 and proceeding with the result, until the number 1 is reached, which it always will be according to the Collatz conjecture. Now, instead of using the Python debugger, I'm going to start in a free online service called Python Tutor. There is a link in the description, but it's pretty easy to find. It's just pythontutor.com. I really like pythontutor.com for visualizing code running. If you watched the recursion problem-solving video, you saw my drawing of the call stack. Python Tutor will do that for me, and it will be a lot neater. So I'm going to copy my program and paste it into Python Tutor. To keep this focused on the recursion, I'm going to just define hailstone and then invoke it with a value, rather than running the version of this with the user interface. So I copy my program, I go to Python Tutor, I click Start Writing and Visualizing Code Now, and I tell it the language I want to use, Python 3.6 in this case, which is the most recent Python available. And then I paste the code in, and I click Visualize Execution. Now there are some ads. Python Tutor is free, so that allows them to keep the service free and running. The important parts of the screen are the code, which has a red arrow pointing to the next line to execute, and a green arrow pointing to the line that just executed. You don't have to choose between over and step, like you do with the debugger. Python Tutor will always step into your code, and it will never step into Python's code when you press the next button. Now, over on the right, you can see frames and objects. The frames are the frames on the call stack, and the reason we're in Python Tutor is because it's much easier to visualize them here than in the Python debugger. I'm going to click the next button until we get down to our call to hailstone. And you can see in the frames the global frame and the name that's defined, which is the hailstone function. Okay, I'll click next again, and it jumps up to the call to hailstone. Notice a frame is placed on the call stack with the title hailstone, the name of the function, and a spot for value, which is 12. That's the value I passed in, the parameter. Now these frames are getting added below each other. I normally draw them in the other direction, but that wouldn't work in a web window, really, it would be confusing. So hailstone is on top of the global frame. It's the newest frame on the call stack. Let's click Next and go in. You should pause this video as needed and ask yourself what's going to happen now and what you expect to see, and then continue running it to confirm your expectations. It's really important that you can predict the state of a program's variables during execution, and that you know which lines are going to execute next. So as an example, we're on line 10 if value equals 1. True or false? Take a look at value. It's 12. So where will we go next? I press next, and we're in the else on the if value mod 2 equals 0. True or false? Where will we go next? It's true, 12 is an even number, so we'll go to line 15. On line 15, we're going to append a string version of value, 12, to the result of another call to Hailstone, passing in value flooring division 2, or 6. Let's click until we get in there. Now look at what happened. We have another frame on the call stack for Hailstone, and this time with a value of 6. The other call is still there because we were inside Hailstone when we called Hailstone again. When we return from this call, where the value is 6, we'll go back to the point in the code where this call was made, line 15, with the return statement and concatenation. I'm going to slowly click Next through all of the calls to Hailstone. Watch the call stack grow, and watch the values in the variable value change. Please pause and make predictions about which lines are going to execute and what you're going to see on the call stack next. Okay, look at all those calls. I wouldn't say this is a long Hailstone sequence, but it's much longer than our example of 16 in the last video. So please pause and make a prediction about what's going to happen now that value is our base case value, and our base case condition is going to be true. Here we go. Okay, now look at what Python Tutor does. It gives us a message about what's being returned from this most recent call to Hailstone. And now predict where we will go when I press Next, and what will happen to the call stack. I'm going to press it. That was quick, right? We went right back to line 15 in the previous frame, the previous call to Hailstone, and it assembled the return value of value, comma, and what got returned from the previous call, 1. And now that's the return value. I'll bet you can predict what's going to happen next. Let's press Next. Okay, again, we're on the next frame in the call stack, or the previous frame, and our return value is the string 421. I'll keep pressing Next slowly as we go back. When the value was an odd number, we'll be returning to line 17 and not line 15, because line 17 is the recursive case line that we'll have executed. Let's go all the way back to the first call. It's kind of fun to see that return string accumulate as we go backward, isn't it? That's what a recursive function does. Solves the piece of the problem in front of it, operating under the assumption that the rest of the problem will be solved with the correct call to itself. In this case, we assume that a correct call to Hailstone is going to return the Hailstone sequence, all except the current value we're looking at. So we just need to append the current value to what we get back. Now, what sort of errors might we see? Well, as with loops, an off by 1 error is common. Sometimes that happens if you don't identify all of the base cases or you don't identify them properly. Let me check for value equals 0 over in Python, and we'll see what happens. Oh, this looks bad. It says maximum recursion depth exceeded. That's like an infinite loop. It means we kept calling the recursive function until Python decided enough is enough. Python has to limit recursion depth because it's memory intensive to create so many call frames. Why did this happen? Well, we can't get to 0. Remember, we're always going to get to 1, according to the Collatz conjecture. So we got to 1, which is not divisible evenly by 2. So we multiplied by 3 and added 1, which gave us 4. We divided that by 2 and got 2, divided that by 2 and got 1, and then we're back where we started, multiplying by 3 and adding 1, giving us 4. Ad infinitum, or odd recursion error. Let's put that back. Suppose, instead of appending value to the next call to Hailstone, I appended value divided by 2, or value times 3 plus 1, depending on which call it was. Let me show you that. Okay, and you can see nothing as bad as a recursion error, but we have the wrong sequence. The middle numbers are okay, but it starts with 6 and ends with 2 1s. What if we appended in the opposite order? That's not so bad, it's just the Hailstone sequence reversed. It should be clear how that happened, but if it's not, run it in Python Tutor and see. I hope that's helpful, and I hope you enjoy the pythontutor.com website as well. Use it to visualize other programs like ones with lists and other functions. It can be very helpful. You can practice in the description below writing this program if you haven't worked with it before. You might also try writing, and maybe debugging, some of the recursion problems from the end of Chapter 7. When you get the hang of recursion, it is really fun to solve problems recursively, because it's like solving a puzzle that suddenly snaps into place. Have fun.